I make. Mike, can you hear me?
Hey Mark,
Hi.
Happy New Year. I haven't seen you
Happy
last
New
week.
Year to you too.
Hey Mike.
Um, yeah, Mike is not responsive. He's just a ghost on the screen. Marina, hi, you're new here.
Hi, yeah.
Uh,
Yeah, I work at Adara. I'm just interested in learning. So, hi.
okay, sounds good.
Hi Marina.
Mike just disappeared. Okay, now, Manu, while you're here, nobody else joined. So I had a good conversation last week with Peter Castleman. So if you remember, he is one of the principals on Whimsy working
Yep.
group, and
And I did
they
watch the video, so I'm actually caught up to what you guys do. But go ahead with
no, but
the
we had
discussion.
we had a sort of a one-on-one phone call, and basically in that, what we decided in that call was that we are going to submit to. So Whimsy does not have time for us in Shenzhen. They are basically just taking up existing
Okay.
work. They only have an hour. Besides, nobody's going to China.
Right.
Nobody I know.
Yeah.
So it's going to be probably fairly lightweight. But the uh, what he did say is we don't need IETF for you to do what you need to do. Just prepare a spec and present it in one of the Whimsy interim meetings. So basically, nice avatar, Mike. As long
Like
as Jesus Christ, man.
it's
What
Second
are we in the
Life. Are we back?
metaverse? What's
I
going
was
on?
Second Life. It's like 20 years ago.
Can you hear me?
Yes, we can.
Oh, I
Oh,
wish I didn't
marvelous.
see you though.
Oh, yes,
Uh,
you can.
anyway, so he basically said we don't need a IATF for this. You can basically, you know, mm, like, author some content and present it to the Whimsy intro meeting. The idea I shared with him, he basically said can be done with no architectural changes to Whimsy, so he's on board with it. And the idea covers a large number of scenarios, not all. So basically, it covers the case where the workload doesn't need to generate and certify its own key in order to get to be in possession of a credential. That's the last of the credential issuance mechanisms in the reference architecture, and that's the two-phase one, where the control plane takes care of the credential provisioning, and the workload takes care of credential acquisition. So, credential acquisition, in that case, I'll remind you, is where the workload first performs attestation and then contacts the key store and fetches the private credential signing key. And then that's outside of Whimsy. That's outside of Whimsy. Within Whimsy, it will contact the agent like it always did and ask for the public portion of the credential. Right? So
Sorry.
just a certificate, no private key, just the width, no private key.
So the
Apparently,
the workload is asking the agent, right, to fetch its certificate.
It's public credential, what we call
Right.
so we
Which
make
is the
distinction.
certificate essentially, right?
Yeah. Right.
Yeah.
So that can be done with the workload API. That can done with basically without any change to WIMSI. The only thing is today the agent will fetch everything, and under this proposal, it fetches just the public portion. But so the first part, the provisioning phase, is done by the control plane. It was all documented in the swim lanes. I'm just like walking you through it just to refresh memory, where the control plane generates the key inside some key store without learning the private key, and then creates an author's. Welcome back to our world, Mike. I
Hey,
much
Mike.
prefer your real world faith. All right.
Yes. You're beautiful,
All right.
Mike. We don't need the
You
avatar
are, yes, you
for
don't
you.
need any of those embellishments. Anyway, but the Starry Night behind you, that was nice. All right. So uh so behind so the the control plane creates the key inside the key store, creates a credential with that private key as its backer, and basically serves that into the credential. So one way could be just mounting, so outside of WIMSI, that could be just mounting the credential on a volume that the workload can pick up when it starts, or under WIMSI, workload starts and can call some workload API to get the credential delivered to it, right? So we then talked about, so what's the delivery mechanism? So it doesn't really change anything in RATs, right? In RATs, the workload will effectively do remote attestation with the verifier, get attestation results, take these attestation results unmodified, no change, directly to the key store. We already do this all over the place, right? This is basically the beauty of this otherwise ugly solution, is that it reuses the existing primitives effectively wholesale. So what happens today is the attestation results go to the key store. The key store responds with the key store is effectively impedance matched to the verifier. It understands the attestation results that the verifier serves, right? So that's why you can't take these attestation results from Microsoft and send it to Google. Like they will not understand that it's just not how it works. But today
Well,
it just serves the
in a cloud centric way, yes. In
yeah.
a cloud centric world, that's not how it works. Yes, got it.
Unfortunately, not today. Maybe
Yes.
eventually, right? So, but the still this works with container orchestration as it happens today. It also works under WIMSI. So, basically the idea was we document this. We make this what Peter called a WIMSI profile. Okay, so there is. I actually went looking online. I've seen WIMSI profiles before. I couldn't find an existing profile. Maybe just maybe I need to ask like a chatbot or something, better searchability than mine. But we create this WIMSI profile. We explain how this works, and then we effectively have WIMSI, to finish it with us to make sure that the language is appropriate and all the T's are crossed. There are some security issues with this that we need to be very careful. The security considerations need to be carefully worded. I can think of a couple. So there is clearly an issue of how do you deliver the signing key to the workload. The workload needs to effectively attest to an encryption key. And then we need to worry about things like replay, relay. I just do a full threat model analysis of this. Usama was talking to that
Yeah,
at the
I've
last
seen that. Yeah.
ATF. And I mean, absolutely, we can't ship a protocol that has a security hole in it. So we will need to carefully take a look.
Why not? Never stopped anyone else.
Yeah, I was about to say,
we're better.
that's the world we live in
better.
today. We just ship stuff with no
We're
consideration
better than
whatsoever.
that. Yeah. So no, I certainly will not have my reputation sullied by
Of course not.
a Swiss cheese protocol. Okay. So we'll do that. Now that brings the other question. What are we going to do with rats? Because this doesn't change a thing about rats.
Can I react? Can I react
Please.
to some of this? Because
Yeah.
I did watch the video. And by the way, Mike, I'm very interested also in the AI agentic identity stuff.
Yeah, I saw
sent you
your
an
email. I'll get
about
back to you.
yeah. And in fact, the two connect here because I do think, Mark, as we've discussed all along, what we're trying to do is a continuum that works for the most, stringent, secure, most sophisticated use case of an
Yeah.
agentic workload, all the way to what we currently have today, which is containers that just need to get some identity and some way to authenticate themselves to others, right? Which is what you are working on right now. So the one thing that made me react, and I don't know if you want to put that in Whimsy, is the key exchange or the key provisioning. Is that going to be part of the Whimsy profile also, or just the fetching of the certificate by the agent and passing to the workload? Because
My instinct is to make things as succinct as
lightweight, right?
possible and mention as few things as possible.
So I would think that the key, then delivering the private key to the workload would stay out of the Whimsy stuff because they don't do that anyway, and they would not be involved in that, right? That's
Well, we need to. Yes, uh, it's just the thing is if we just say, well, under Whimsy you will fetch the public portion of a key. How do you achieve coupling to the private key, right? So
right.
now notice
But
here
through
that
the
there.
certificate itself, right? Through the
So
certificate itself.
so let's take a look at this. Just so basically, there are two parts to this proposal. The first part of this proposal is from the point of view of the control plane. Okay,
Yeah.
from the point of view of the control plane, we have no idea what the workload does. We just specify a set of steps that the control plane needs to do so the workload can be happy.
Okay.
And then the second view of this is from the point of view of the workload. What does the workload do?
It
Right?
talks to the
And the
agents, right?
workload, you wake up, you're a container, right? In fact, now you have two paths. You're under Whimsy or you're not under Whimsy.
Right.
If you're not under Whimsy, then, well, you have some knowledge of where to go find the credential, and that is usually some volume mounted inside your container, or maybe some other mechanism, who knows? If you
Yeah,
are
some
under
other
Whimsy,
mechanism.
you're not
Yeah.
reading some volume that's been mounted inside of you. You go call what's called the workload API, and that will give you a certificate. And then in the first part, where I say from the point of view of the control plane, you don't talk about the fact that workload needs to go fetch its private key. I mean, that's, workload will do whatever workload does. And in the second part, you don't talk about what the control plane does to enable it. They are, I mean, they're part of the same thing, but they're really just, what Scott Adams calls,
and I
two
think
movies,
I
one
think
screen.
there's the third part then, which is the actual, transfer of the private key from outside of the workload to inside of the workload, right after attestation, because we are talking about, matching Whimsy patterns to the confidential computing workload way. Yes.
Yes, I would even actually go stronger. I'm inclined to mention one other thing in there is that say I'm a Lambda function and I keep firing on the same server, same code, same configuration, right?
Yep.
And I just keep firing, running for 15 seconds and off. Should I be calling my key store every single time? Ideally not, but this is where this sealing to the platform primitive comes. We might as well specify it and say, look,
Got
for
it.
as long as your, credential didn't expire, you can go keep doing that. And then, there are actually two other things. We need to talk about rolling over of the certificate. So at some point in time, we simply want to say, well, a lot of certificates today issued for minutes at a time.
Right.
All right. But even then, the certificate, when it's reissued for the next time slot, it could reuse the key,
It could. Yes.
right? And the second one is the key itself needs to roll. In that case,
yes.
everything changes.
The
So I
key
like all of
rotation,
these
yeah.
things. All of these things need to be written down.
But not in Whimsy. That's what I'm trying to say, right? Not in Whimsy.
Yeah. So that's the question is, so what is the target audience? So we have Whimsy as a target audience, and they need few things, right? Not everything. We have rats as the target audience, perhaps. I do not know. Like, I want to keep the rats flame alive, but mostly because the rats need to understand the workload identity is not a second order concern. And then separately, we have guidance to implementers of confidential workloads. Like, what do you
Okay.
do? Right.
Okay.
So, I mean, I don't even, we need to just agree on what the mode of delivery is going to be.
So I wanted to talk about that in particular. I mean, not the delivery of the
So you
documents.
want to talk basically with the Hashmesh head on, right?
Well, not really. As like I think in the discussion last week in the video, you mentioned that today confidential computing workloads after attestation essentially go and fetch an encryption key, and you say, well, that's not what we need, or that's not what we need really is a signing key for the workload to authenticate itself. And so you say that would be a deviation from what people traditionally do. They go and they would go fetch a private key instead of an encryption key, a secret key. What I'm suggesting, because that's what what we do and realize that we had to do, and that I think is necessary for agentic workload, is that the let's say instead of fetching the private key, that the key store would wrap the signing key or the private key, right, with an encryption key. So would encrypt the private key, would store the encrypted private key with the certificate on whatever volume or delivered any way you want. But then the attested workload can just go and fetch the encryption key that enables it to decrypt its private key. So it's one more step, but that preserves the paradigm of an attested workload recovering an encryption key or a decryption key to decrypt its own information. That would include the private key that would have been wrapped with that secret key. And the reason why this step is important is that then it opens the door to the next step, which is the workload itself is generating its own keys, its own, in our case, our STEM ID or its own root key, its own secret keys and whatever. And now nobody outside of the workload itself has any access to any, private key or secret keys that the workload is relying on. And now you can decouple the key store where the encryption key comes from. In our world, it's called the stem cell key. And you enable the workload to retrieve its own keychain that can include whatever it is. And now you have assurance that only that specific workload can act on its own behalf. That's the exclusive agency capability. So that single step of wrapping a private key, and I agree with you, right? In the current world, the workload, only needs a private key, as if it's just a container or the Lambda functions or whatever. It can even seal it locally. But by adding that additional step of wrapping the private key, putting on the workload, on the volume or wherever, and then having the attested workload retrieve an encryption key, you have the same pattern that will then scale all the way to agentic workloads that have exclusive agency. It's the recursive chaining that we have in the mesh that enables us to have the most, smallest attack surface possible by collapsing then. So the next discussion that we need to have indeed is around the security, of this architecture. And that's where Usama is pointing correctly that there is all these attack vectors. It's because of all the seams. But if you collapse the control plane, the identity, provisioning, and then the key management into one, chain, which is the attestation verification chain, then you end up with no or the smallest attack surface possible. So going back to what we had discussed over the past year or so, let's architect or let's propose something that scales all the way up or all the way down, whatever you want to think about it, to the most optimal, smallest attack surface, security posture, and then relax that and have the same pattern works all the way. Does that make sense?
It does.
So the only difference, right, is that instead of the key store passing the private key directly to the workload, there would be another step, a wrapping of that private key, and then the workload just gets a secret key from the key store to retrieve its own
Secret
private.
encryption key.
That's right. By secret,
Right.
yeah,
Yeah,
symmetric.
right, and the problem of securely delivering an encryption key to a workload must have been solved already, It's just the thing is, again, you need to worry about safety in transit,
I mean,
right?
that's exactly right. And I mean, you do have, so what Usama is putting his finger on is that if you want to, he's thinking about the true full use case where there's different, how do you say that? Legal actors, right? Different organizations or different types of individuals that have access to the machines, and that you could insert that basically the security perimeter is how to say that there is no trust, right? We are discussing right now something where JP Morgan essentially is managing the key store and the workload, and you guys have a security perimeter around both of them. And that's fine because then the only thing you need to do is protect indeed the exchange of the secret key,
Yeah, but
the
that is,
encryption key.
our use cases also include, multi-institution
I,
type situations where, like, yeah, mainline case, yes,
possibly,
our
possibly,
walled
possibly,
garden, but we're
but
not a
but
walled garden.
no, no, no,
Okay,
no.
but I'm actually agreeing
Possibly,
with you. Like, I
but
hear you. Yeah.
the attack vectors that Osama is teasing out is basically saying you can't get rid of I forgot how you call it, the redirection or whatever, or the man in the middle. Essentially, it's a man in the middle problem because the workload
Hmm.
doesn't have an identity before it talks to anything else.
Yeah.
So in that world, you always have the question of, am I actually talking to the workload or am I talking to
Yeah.
somebody who pretends to be the workload?
This was,
Uh,
by the way, let me, yeah, I just want to show, put something on the screen.
so
That,
I think basically I'm aligned with what you guys discussed last week. I think it makes sense if we just make that one change, then our architecture falls squarely into what you are
well,
recommending.
look, what's not
Uh,
to like, right? So,
yes,
I just wanted to show you this one thing. So this is, by the way, straight copy and paste from the working documents we've had. And this is actually straight out of the reference architecture. This is the provisioning phase. So again, we can go revise it. But the acquisition phase, this is what we're doing in the reference architecture today, which again, not cast in stone. We can change. If you have a better idea, like you just said, let's just go redraw this thing. But you generate an asymmetric encryption key, and then you generate evidence that yes, this workload really did a test and really does have this public encryption key on it.
but hold on, because you told me that the private key was coming from the key store. Now
Signing key,
this,
signing key. This is encryption key.
okay.
This is not your certificates key. This is just a transport key for whatever you want to get out of the key store.
Oh, transport key. Got it, got it. Sorry, it's basically a key exchange,
I
a
should
TLS
probably
or whatever.
rename
Yeah,
it public transport encryption key.
yeah, yeah.
That's the transport key. And then so again, this is not cast in stone. This could be a variant, or it could be deprioritized in favor of what your proposal, which I actually like I think it
Hi,
has
Mike.
really good truth to that, I think. So
Yeah.
the idea is here you encrypt the credential key, that's the signing key in step 9, to the transport key, and then you do that. But again, in this case, what happens, you end up having to go to your key store every single time for this, where what I heard you say was you could get both of the certificate, the public portion, and the wrapped signing key from
Correct.
your agent, and
That's
then
right.
instead of procuring from your key store a signing key, you procure from your key store a wrapping key,
Correct. And you
which
could then, and then you can then seal, right, that wrapping key so that you can do everything that you also wanted to do. But now you have that separation of
yeah, the
concerns.
only difference there is this, because the transport key under this model that I have on the screen is attested as part of the workload. You're talking to the workload. Under the mechanism you specified, you need to still establish on the key store that you are giving your wrapping key to the right workload.
Now you can keep, if you want to keep the this key exchange, right, to have your essentially your session key bound to the, to that workload. That's fine with me. You just use that transport pipe to then pass the wrapping key
The
in there.
wrapping key. Okay, so
So it makes no difference.
this is excellent because yeah, we could probably, but by the way, when Osama saw this, he also thought that there were some relay attacks in there, and
I guarantee you that there is. Yeah.
yeah, there is.
I,
But I don't call my baby ugly. You have to prove it to me that my baby is ugly. Like show me how my baby is ugly.
I
So,
know, I know.
and that's because
I
it's
had
kind
long.
of hard for me to see that.
Osama, if you watch this, he had also some concern about what we do, and I think he's coming from the right place. He really wants, precise security, but we need to come up with something that exists that works, and then we can poke hole, and then we can try to,
Yeah,
improve that thing. But
yeah.
uh,
All right. So we will need a volunteer to write this up. I mean, it could be me. I'm just want to give somebody else the right of first refusal because I'm also have the GRC and I have like a lot of things on my plate. Hank, I wanted to talk to you. You joined late, so I'm gonna have to do a bit of a replay for you. Just want to make sure you're actually listening. You're muted. Just
Yes, I am.
hi.
I'm trying to
All right,
switch
there
to
you are. Okay,
headphones
hi.
right now. So bear with me. Yeah.
Yeah, so I had a discussion with Peter Castleman, so he's one of the principals on Whimsy, and we're talking about for the next step in our IETF engagement to propose to Whimsy something that works without any architectural changes to what they're doing. He liked the proposal. It doesn't work for everyone, this proposal. It works for a class of workloads that I call, short-lived horizontally scaling workloads. So containers, Lambda functions. And the differentiating feature of these workloads is they don't generate their own credential key. They get critically share the same cryptographic credential key material with other workloads that are their twins. So same code, same configuration.
Okay,
And
it's a group key. Yeah.
it is, yes. Okay. And the beauty of it is because the workload does not need to perform attestation with the Whimsy agent, it can simply go to the agents and say, parameterless, give me my credential. And under that mechanism, though, it will give it the credential, but the credential is unusable until the workload performs remote attestation on its own outside of Whimsy with some key store and obtains via either directly or some wrapped form something that unlocks the use of the credential key. So we're going to document this. And Whimsy just basically said, write it up and show it to us in an interim meeting.
Okay.
That's
I was
fine.
trying to follow that. I am not entirely sure I could follow the whole.
Okay, so let me just say that we have a path that I'm happy to walk you through in the next few minutes. That basically says we can reuse the Whimsy architecture exactly, so long as each workload doesn't get its own bespoke credential with its own key that it generates, but actually is a group key scenario like you. So we have a way. We believe it works. Whimsy basically said, bring it to us to our intro meeting. We'll call it a Whimsy profile. We'll publish it. Off we go. So that's the good part. My next question is, this also changes nothing about rats. So what happens under rats today is the workload attests, it goes and presents, and this is, by the way, this is mainline. This is what every confidential workload does today, I believe. It performs attestation, and then the attestation results go to some HSM, some key store. And the key store understands the attestation results, so it's effectively coupled to the verifier. So it understands the attestation results in whatever format the verifier serves them, and basically gives back to the workload some sort of decryption key. And then the workload can access all data encrypted with that decryption key. So there is no change.
Goal here is that the workload is showing that it's healthy, and only if it's healthy, it can access all the required data. Is that what I hear?
Correct. Yes. If it
That's
matches. That's effectively what happens in all scenarios today. Now the question
Okay.
is, we're not really changing rats. So with this proposal, there is nothing for rats to do. They're like,
Yeah, maybe we are
uh,
reusing something in red. So,
all of it. We're reusing all of it.
wait a second. So let me. This is a clarifying question. Another clarifying question. So, all workloads are clones, technically, with the same key. Sorry, with the same identifier, not identity document. Some
Yes,
identifier, which is a URI, and
yes,
I think in Whimsy, and so they have the same width, I assume.
yes.
And having the same width, how are they distinguishable by the verifier, or is it not
They're
relevant
not.
that all
They're
these
irrelevant.
attesters
They're
irrelevant? Because
irrelevant.
that is basically like the direct anonymous attestation scheme, where you have a group certificate and a group key, and you can join a group and then if one workload fails remote attestation, all of the clones are distrusted. The whole group fails.
If one of them leaks, yeah, if any of them one of them compromises the key, then the key is gone. Yes.
Yeah, compromises the key is not what I'm highlighting at. That's also true, but that's more like I lost my attestation key, the evidence signing key. That's of course bad. That now you can falsify evidence. That should never happen, I think. What can happen is that one workload just is failing remote attestation because it's running on a not appropriate platform, or maybe because it actually was runtime compromised. But it would be healthy again if it would start from blob.
Well, then I wouldn't be
So
able to get the key. But
well, initially, yes, and then it got compromised after key acquisition. So what gives? I mean, it really all depends on what you're doing when. You can only guarantee here if you do one remote attestation cycle that at the time of key exposition, so you can decrypt relevant data. At that time, it was healthy. If a millisecond later a vulnerability and a listening service of that,
yeah,
I don't know, serverless thingy exploited, this
yeah.
the data is gone.
Right. So you deal with that. You deal with that with key rollover. So maybe every hour you change the key, but at least
So you
you
want to
you.
do runtime attestation, do evidence once in a while.
It's something like that, or like I mean, yes, and you basically
Okay.
your credentials are short-lived. Your key may be medium lived. It's, but the thing is, for us to work with Whimsy, we have no way to incorporate, like without changing the Whimsy reference architecture. We cannot have Whimsy participate in the workload's remote attestation. That's not possible. That would be the next step. So we're basically saying,
Yeah.
what can we do right now without changing Whimsy? And then, we can eventually deprecate it if we find something better, but at least that gives us a path forward that unlocks some number of use cases.
Do we augment the width for this scenario, or are we using a normal width? I still do not really understand how testers identify themselves.
So today, let's just forget about rats for a second. Let's talk about Whimsy.
Okay.
So
Yeah.
on Whimsy, there is a bunch of workloads that they run on what's called a node.
Mhm.
Node, think of it as a server, but there's a node. The node attests, and the attest doesn't necessarily mean in the remote attestation sense. It's basically somehow proves what it is to
They
what's called a Whimsy
assert.
server.
Yeah, they
Yeah, it is cert,
assert.
basically.
They
Yeah.
assert. They don't attest. Yeah.
Yeah, it is what they call it a test, but yes, it
I know. I
asserts
know. I'm
it.
yeah.
Right, so correct. And then the agent runs on the node, and workloads call the agent and through what's called a workload API. And the agent knows who the caller is. And we don't ask questions how, it just does. So the agent knows the workload's running on the same node as itself. You're like basically out of band because the workload API is parameterless. And then the agent goes to the server and fetches all the credentials for all the workloads running on the node. And then say there are workloads A and B. Alice and Bob running on the node. Alice goes to the agent, says, give me my cred, and the agent gives it Alice's cred. And Bob goes to agent, says, give me my cred, and the agent says, well, here is Bob's cred. And we don't ask how the agent can tell between A and B, but it does. And effectively, Whimsy assumes no isolation between workloads on the same node, and it's the node that's trusted, and the node asserts its identity. The workloads under Whimsy don't attest anything, but still get a credential back.
So this works in in scenarios where the agent that is located on the node where all the workloads runs is aware of all the workloads.
Yes.
And how is that in any way related to the confidential computing scenario? I mean,
well, as this is what I pointed out when we did our Bangkok presentation last April, or what was it? March. That's the IETF 122. That's our Whimsy extension. So we basically said, look, Whimsy is not compatible with confidential computing because Whimsy does not allow workloads to test themselves. So we basically said, here is a set of things you might do, but there is resistance for Whimsy to do anything immediately, maybe eventually, because they have all this actually installed base, the parameterless workload API and whatnot. So we're basically now saying, okay, Whimsy, if you allow us to, to do exactly what we're saying here, we will fetch the public portion of the cred from the agent via mechanisms that exist today, but with no loss of security because we're just sharing public information. But then separately, outside of Whimsy, the workload will retrieve the public portion of the cred and do its own dance of some sort to unlock the use of the corresponding signing key. And for that, it will do attestation. So Whimsy doesn't care. Whimsy says, here's your cred, go party. And the workload says, I will party in my own way by performing remote attestation, unlocking the use of the signing key, and then I can make use of this cred.
So, okay, what is actually input to the function that unlocks the signing key? What is the input to that function?
So this is now inside the workload. The workload went and obtained the public cred via workload API by reading it from a volume,
public cred,
whatever.
You mean, for example, a X509 certificate?
X509 cert or WIT, yeah.
Okay. Or a WIT. Okay, good. Both possible.
Yeah,
okay.
either. So something with an SVID. Now what it basically does, it says, okay, I'm going to go perform remote attestation with the verifier.
How?
Well, how does a workload talk to a verifier today?
Yeah, the workload has no root of trust, no...
No, it's running in a T. It runs in a T.
Okay.
Hey, may I bridge the two guys, the two of you, because
please.
So Hank, what Mark is looking for is a unified approach for workloads that don't run in TEs, and that's the Whimsy world that exists today. And he wants to be able to make sure that when a workload is migrated into a TE, that as many things as possible stay the same. So essentially the whole Whimsy thing, and then that a workload that runs in the TE would then do something extra to then get all the benefits of the attestation process without breaking what existed before. And so essentially the relying party not needing to know whether or not the workload is in the TE or not. And so that's the junction here. In the scenario that Mark was explaining, the workload is running in a TE. In the case where it's not running in a TE, then of course there's no attestation, and the relying parties are just they don't care. That's the way it is. If it runs in a TE, then it goes to an extra step, which is the attestation, and then that's where Mark was.
But if I run in a TE, who is typically or what part of the system is the origin of the evidence? It is the TEE thing itself, like the AMD SEV attestation report, right? That is
Yes.
not coming from the workload, it is coming from the platform. The workload is not conducting any remote attestation here. So is that what we are doing? Or is there actually some root of trust inside the TE provided by the platform so it can really be an attester? So you lost me on that part.
Okay. So, Henk, let me put it sort of in the context of what happens today, in deployed code out there.
Okay.
So I'm running some software on I don't know, in SGX. I have two enclaves, enclave A and enclave B. And they mutually distrustful and they need to access different data. Enclave A performs attestation in order to get a decryption key to access data that are destined for A, and B does the same thing, right?
Yeah, but the function inside the SGX is not doing the remote attestation. The platform host providing the SGX function is creating the remote attestation. That is very important. Also, I don't think the SGX is designed to do internal remote attestation. It's always evidence is created by the platform, right? So
I
that's
believe you ask for a quote from inside the T, but then, yeah, you pass it to a function outside of the T to actually go talk to the verifier. Like the enclave has
yeah.
no
For
network
example, a
stack.
quote. Let's do VTM as an example. Yes, for example, VTM could be running inside the TE and create a quote, for example. So, okay,
Yeah,
then there's a tester inside in the environment, but
yeah.
typically that is generated outside of the environment, and both is a part of the solution, I think. And what I'm not getting is what in the very simple scenario with the simple whimsy dance is happening. What I think you're saying is that the platform is generating evidence, but I'm not sure.
Well, the point is here. Look, let's just pop up a level. The point is there is no difference
Uh-huh.
in how the decryption key gets inside the T. It's reusing the exact same mechanisms that exist today, right? So we're basically saying, look, the workload is handed the public portion of the cred via a mechanism that Whimsy knows about, and it's handed the uh, an ability to decrypt, and this is now I'm reusing Manu's early idea. It handed the ability to decrypt the corresponding signing key using mechanisms that are already used for rats. So we're completely reusing two mechanisms. And
And
the
what is
the
the
only
second
delta,
mechanism we use here? So what mechanism are we using to fetch a key to open up, to unseal a signing key? And where would that signing key live inside the workload? I was
okay.
very
So the mechanism used to decrypt is the same mechanism that every confidential workload uses today to get access to encrypted data that lives in an outside place.
so
And
that's CCC. Okay.
right, and the difference with Whimsy, it's a small but perhaps relevant delta, is that the Whimsy today hands the credential and the corresponding signing key to the workload in plain text. And under this proposal, the only thing that actually changed is the agent, the Whimsy agent, hands to the workload the plain text public portion of the cred and the wrapped signing key.
Wrapped meaning wrapped in what?
Wrapped in a way that only by performing remote attestation and getting access to the unwrapping key can the workload actually get it.
It's encrypted. Okay, wrapped means encrypted.
Yes.
Okay, got it. Okay.
So the question to you specifically is I would very much like in 2026 to keep the workload identity light glowing inside rats. Right? I do not want rats to treat a workload identity as a second order concern. Except in this case, we're basically we're discovering a workaround that allows rats or confidential workloads to get identities without any change in rats. The only thing that I'm still concerned about, because this will work. Like this will work. We'll figure out how to make it work with Whimsy. We'll do some prototype. The whole thing will be fine. But the thing that concerns me is because this is for the subset of all workloads that are in the group key domain, like you just called it. I like it. Right? If a workload wants its own individual credential that is not shared with any of its twins, where it basically, this is the other three credential acquisition mechanisms from our TWI reference architecture, from our Montreal IETF. In every one of those, the workload generates its own credential key, asymmetric signing credential key, and then uses RATs to certify it. Right? And we're basically saying, like, do we backburner it and basically say this will never be done, RATs will never ratify it, any of these, or do we say we can still continue making that possible? And that's the thing I wanted to talk to you about. Like, what do you
I think we
what do
have
we
to
do?
present this to the attestation SIG and CC and talk this through with them. Because you were highlighting you want to prototype.
Yeah.
I think, yes, because I am still not 100% sure that I get it. I think I do. So what we are doing is we are basically not doing RATs actually. What we're doing is we're doing typical workload dance like in Whimsy, and also if we are lucky have in parallel CC platform attestation. And then the third option, which I could not really follow at the end, was what if one of the group keys will, because they're in Whimsy dance, all these workloads are basically clones, wants to be an individual. Yeah, I don't know what the implication for Whimsy are in this case. I guess it becomes its own group and thereby an individual in its own
Yes.
group.
So Whimsy, again, the implication for Whimsy is simply that there is going to be a Whimsy profile. I believe we can handle that with Whimsy without any RATs involvement, but it's going to be a Whimsy profile where the workload, as I said, the delta is instead of getting the plaintext cred and the plaintext key, it gets a plaintext cred and a wrapped key. And and that's it. And the workload on its own will then go and unwrap that key, or it won't, depending on whether it passes attestation or not. But Whimsy, right, basically washes its hands off of it.
Yeah, I'm still unclear on how remote attestation actually conducted here, but that's maybe not the important part. What I now want to again clarify a question: a VIT is always injected into the workload. It is never generated by the workload, correct?
Correct.
Okay, good. So that's why
But
that's
I
how
would
you
like separately, I would like to see, can within RATs, that's my question to you, can within RATs something be done such that every workload can generate its own credential key and then use a form of RATs dance to certify it? What I call by certifying it is basically having a credential issued for that private key without releasing the private key to the world.
Yeah, so now I'm differentiating, so to speak, trusted computing and confidential computing. So leaving confidentiality aside for now, I think if you have a appropriate protected capability like a VTPM inside the workload, all of these clones of workloads can have those available. And then you could, in theory, use that to conduct remote attestation, because that VTPM could roll a new private key pair for you. But then it's still like a private key pair for you. But it's still a little bit difficult for me to understand how it would be known to the outside world what evidence signing key is used and why it is on that workload, because you have to kind of put trust into it. So you have to put trust into you have to endorse somehow the function that creates the signing key for evidence and
I,
then measure the system. And I'm not entirely sure how that would work.
yeah,
No?
I think the scenario that includes whimsy does not provide all the assurance that you're looking for, Hank. So it is clearly a degraded security posture, but it's better than no attestation whatsoever. So that's what it's an intermediate step, right? Between, whimsy, there's no that is the node is trusted, the backplane is trusted, the credentials are passed in the clear without attestation. Then there's the right thing where everything is attested, the evidence is generated, and all basically everything is cryptographically bound. And this is a step in the middle. And because what Mark is looking for is this migration path, this practical deployment of confidential computing capabilities that provide incremental security in the sense that every workload will have to go through attestation before it can connect with another, and it protects its information in use using the existing widely deployed, cloud foundation CNCF whimsy thing that's out there. So,
Okay.
so you can never square the circle. There is, and that's why I'm saying, right, the work and that you, Hank, and Usama are also emphasizing, which is what security guarantees do we get, right? I think we basically say, okay, there's these three ways of doing things, and each one of them has different security properties.
Okay. So I think I'm getting there. So to use Red's speak, the inside this workload, this one of many cloned workloads, inside there, the testing environment is not isolated from the target environment. They are the same execution environment. Is that correct, Manu?
I'm sorry because I'm not as versed with the term. Say that again. Within the
So
workload.
within the workload, the testing environment, so the environment that creates the evidence, is not isolated from the target environment, which is the environment you create evidence about. There's no isolation.
If it's SGX, for instance, I'm familiar with SGX. So SGX has a quoting
Yeah,
enclave.
yeah, but
So
exactly. In SGX, so the quoting enclave would be the testing environment, and the other enclaves would be the target environment. But
okay,
that is just SGX function. SGX functions are passive things that have to be called. What I'm assuming when we're talking about workload here, we are not talking about SGX, but something like TDX. Let's
okay.
say
Could be either. So uh,
either.
so the workload
Okay.
is just, it's per the whimsy definition, it's something that, executes for piece of software executing for a particular purpose that you can,
Yeah.
think
With
about as a
SGX.
standalone entity. But whether it's
Okay.
TDX like a full VM or it's an SGX like an enclave, to me, it actually doesn't matter.
Okay.
So
Okay.
long as you identify it as a thing
Yeah.
that it is.
Okay, but so because SGX can't do things by themselves, they for also other reasons need the special purpose SGX enclave to create evidence about the other SGX enclaves. And Manu, correct me if I'm
Oh, you mean
stating
the
this wrong.
quoting enclave?
Yes, that is the attester literally for the other
Yeah.
SGX
Right.
out there, and because there's no other way to do it, and otherwise it would break this on confidentiality thing, and the SGX are not safe active; they only react when you call them. So there is no capability to real attestation. You need this external code enclave. Okay, that makes sense to me. And now, in all these functions, if they are asked, they can return the VIT. So the code in them includes the VIT that has been deployed probably by calling them with, "Hi, dear SGX function, here's your VIT function. Now please remember your VIT," and then the SGX code will remember its VIT. Okay, so then you have it kind of provisioned that to the SGX code. And now what? So we basically have now what we're saying is we put widths into TEs, and that allows us, if that is done and the width is there, and then we have the quoting enclave creating evidence, and that passed. Then you can call the phrased SGX code and give it its encryption key, the decryption key. Now it can decrypt stuff in its code and actually work. This is the story for
Yeah.
SGX.
Yes, and then that decryption key that it got after attestation, a successful attestation, will enable it to decrypt the signing key that goes with the wet and with the credential that it got through IMSI. So it can
What
actually
does it want
use
to
it.
sign with that key? What is now signed with that signing key?
Mark, you know the WIMSI thing, and it basically authenticates itself to other workloads with the names within the
Yeah, so
WIMSI
there
names
is
or the WIT
yeah,
namespace.
within Whimsy you are issued this so WIT is uh, WIT or X509, they're both contain this thing called an SVID, and you utilize standard TLS or HTTP protocols to utilize the credentials. There is a whole, like under Whimsy working group, there is an entire document on how these credentials are used, but they're I don't really like
Okay.
if it's an X509 credential, then you just do TLS with it. Like no different.
Okay. So I'm not an SGX expert, to be honest. A quick question. Can you terminate an active TLS session with SGX code inside an
Yeah,
SGX export?
absolutely. Absolutely.
Okay,
You run
wonderful.
MTLS and in enclaves all the time. Yeah.
Perfect. Okay, that's good enough for me. So because I was not entirely sure how reactive the SGX environment is, so it's good
No,
enough to keep
yeah, the
TLS
only
sessions running.
reason you have this whole platform enclave under SGX is, I think, so that your enclaves on the same machine can basically talk to each other. But by the way, they're phasing out SGX anyway. So
Yeah, I know.
going forward, it's going to be TDX. I'm just basically saying it doesn't matter to me if it's an enclave or it's a VM or if it's a container. Like so the high order bit is here. We're talking about groups. We're talking about, large numbers potentially of identical twin workloads, same code, same configuration, sharing the same credentials, same key. And, it's nice because it's a very common case. We have lots of serverless and we have lots of containers. And we also have Whimsy that we can't touch now because of the decisions they made. So we can make this one incremental step to immediately make some workloads deployable with this. But separately, my question to you is this doesn't change RATs one bit. We can basically do this without a line of change anywhere in RAT. But workload identity is still not a second-class citizen for remote attestation for RAT's mainline. And what do we do for cases where each workload instance would like its own bespoke credential key that it generates? We don't have a path forward for that today. And that's something I'd like to advance in this calendar year, if possible.
Okay.
And
Yeah, it really depends on how Whimsy is tolerant to that scenario. I do not know that. We would have to talk a
well,
little bit.
Whimsy, one baby step at a time. Let me get Whimsy to digest this one first.
Okay.
Uh, but
Um,
but here's the thing: even if Whimsy is amenable, is amenable to say, well, we will allow the workload to perform its own attestation. The RATs itself, because of the way attestation results are formed today, attestation results do not contain credentials,
you
so they need
might
to be.
not need attestation rights here because you're doing some kind of implicit attestation.
Is it though?
Yeah, I don't know exactly. So the fact that you send evidence to the verifier, so somehow you are checking the workload that has a VIT already and has a clone, and that workload turns out to be fine. all of these workloads. So you expect, I don't know, you know the numbers of your group. 100 workloads do it, 100 workloads get it. So the group is healthy. And now, knowing that the group is healthy, all of them have the same TLS encryption key. And if you are successful in establishing a TLS connection with a workload, it must be healthy because it can only have that key if it's healthy. And that is an implicit attestation. If it would not pass the appraisal, you would not be able to establish a TLS session with that expected key on the end of the workload. If you can establish the TLS session, you know it's healthy. That is implicit attestation. You do not need to process evidence anymore on the relying party, or you don't need an attestation result. The fact that you can open the TLS connection is your proof. The yes.
We'll have to be very, very careful with this, because so let me remind you maybe I'm misreading what you're saying, but the workload identity for it to be practical, which is practical in my book is the number one requirement. It's actually more important to be practical than just to be secure. Like I wouldn't go that far. Basically, you ought to be able to switch from a regular workload to a confidential workload without its peers even noticing. Right.
Yes.
So whether I'm authenticating to the workload or I'm authenticating to another workload, the workload gets a credential. And that credential is basically credential and a corresponding key that it can use in the same manner it was using it before it was secure with confidential computing, right? So, so effectively, this means, like, if we're going to step away from group identities, so I have this workload, it's the only one like it in the entire world. It generated its own, signing key, credential key. Then it went and obtained a credential around this key via some kind of CSR. Like you cannot do CSR with attestation results today. Simply, I don't think it's theoretically possible. I don't think it's been practically implemented.
It has not been practically implemented. And even the CSR with evidence, I think, is not implemented yet.
Yeah. But this is where I would like rats to go, if possible.
Hold on. I think the CSR step is also a connecting point with what Mark has in mind, which is the long-lived identifier for these workloads, right? That's the thing, is that you want a long-lived identifier that ends up in the CSR request, so that is recognized as an endpoint by other, workloads or whatever. And that's what we're trying to bundle together. And we are trying now to say, okay, identity, the SVID is going to be that long-lived identifier, and then the attestation is going to provide a way to use or to authenticate not human authentication, right, but workload authentication to other workloads, to basically use that SVID and assert its being a that long-lived identifier. And then the certificate authority function is also something that we are, keeping separate today. But again, it comes down to where are the boundaries, what are the trust property or the security properties that you get from it. And I think all of that eventually will need to be collapsed into one attestation process, and then identity, CSRs, credential passing, encryption keys, all of that will need to come from that relationship between the attester and the verifier. But RATS today, like that Mark is saying, RATS has basically not taken into consideration these other things. And all of them have to be bundled or put together into that relationship between the attester and the verifier, eventually.
Okay, but in both scenarios, you deploy a TLS key pair to the workload. In one scenario,
no. Well, what do you mean by deploy? See, critically, what I'm saying is that it's not deployed. The workload generates it and then goes through a dance to obtain a credential around it.
It's in this diagram. It says return encrypted.
Oh no, this is
credential
the
key.
This is the one, this is for group identities. The one that I'm talking about, hold on, let me show you.
Okay. So this is
This
the
is,
just so you do the Whimsy dance, and you are part of the group, and you have a group VIT, and then you as part of the group. Additionally, you stay part of the group, but also become an individual by doing a CSR.
no, you're not part of the group at all. That's what I'm saying.
And I don't get it because you just did
Okay,
the
here,
Whimsy interaction, and then you're part
here.
of a group.
So let me see if this is which one. No.
Mark, is this a realistic use case to have a workload that is a single individual that's never into an autoscale, mode or something? In these day and age, would you have a workload that exists on a single platform, a single chip? It doesn't exist. For resilience, scalability, all that good stuff, you need multiple of them. It's always a group.
Mm,
I would
yeah, I
assume
mean,
so. I mean, otherwise it's a group with one member, but sure.
okay, good point. In which case, rats is perfect, and we don't need to do a thing about it. But this also means that, uh, as Hank said earlier, if one of those keys is compromised, the entire group is compromised, which is perhaps fine.
Yeah,
Maybe,
But
there is
so
work
then
on
it becomes an
DA.
exercise. It becomes an exercise in key management, right? Key rotations, certificate issuance and all that. Then you automate that piece. But it is indeed at the end of the day, you when you test a workload a millisecond later, it could be compromised. If one individual in the group is compromised, you don't know if the others are compromised. So you have
Yes.
yeah,
to rotate keys and certificates anyway.
yeah.
So it really ends up being a key management exercise. And it
Yeah,
has to
but
be
you can do
dynamic and it
both.
has to be
You can be
scalable.
part of a group that is a VIT sharing group. So all the workloads are clones, all have the same VIT, and at the same time you can have an individual um, a certificate and an individual evidence signing key because you have a VTPM and you kind of provision that one. So I guess you can be both. You can both be in a Whimsy VIT group and be a Reds individual at the same time.
Well,
Nothing
what,
precludes you to do that, right?
Hank, what is the use case of an individual in a group? Is it to know
Um,
where
it,
the platform is physically located, I guess?
for example, yes, because you have a distribution, but it's also, again, there are a lot of unknowns here to me. So we're talking about initial startup. Initial startup of workload is relatively easy because you do not get your VIT because you're not in the right location, for example. Okay, sad. So can't become a clone. It's just dead. So that is fine. But over time, when you got your VIT, and now you are migrating. That's good enough for Whimsy. You take your VIT with you. Good. But it's not good enough for us because you just take your VIT with you, but you're in the wrong country or on the wrong platform, and that's not good enough for us.
Well, in that case, you
So
will fail attestation.
yes, and that for that attestation, the whole group now fails because one of 1,000 workloads went to Switzerland instead of Germany.
Oh,
1,000 workloads are done.
no. This is a key release policy thing, right? So basically, you then structure your key release policy in such a way that a workload that's physically in Switzerland will actually rats will need to combine what I call workload attestation with platform attestation. I believe that's already being done. This is your composite attester thing. You're basically saying if the evidence came in and it says workload Alice configuration, valid for Alice, but location is Switzerland, you simply that does not unlock the use of the credential key.
So first of all, I think this is making it way more simpler. I still am not entirely sure what the exact core scope is now. If you include migration, it seems not to be the case, but it includes a distribution of a certificate that can be individual, I think. And it definitely includes the distribution of VIT and clones. So we're starting with VIT and clones. We all get some TLS keys into the workloads on successful appraisal. and then you can connect to them. And then there's other things, and maybe you have to write that up in order for me to follow it better, because then the individual either you do a DAA esque remote attestation, the direct anonymous attestation. That's basically the same thing. You got a group certificate. A group of attesters get the same certificate. That's a group certificate. That's established technology for TPM 2.0 and implementation, which has
Yeah.
just open source actually, but we haven't written about yet because my co-authors are super busy and we didn't do it last year where we wanted it to do. And so,
Mhm.
so there's code for that for the VTPMs and TPMs. Yeah, it's late already. I see that. So, but I think we have to really make sure that we are not doing redundant work to DAA. That's my last message for today, and then I have to take it from here next week.
All right, Hank, thank you so much. We'll pick it up next time. I will try and improve
Okay.
my repo in the meantime. And thank you again.
Okay. Yeah. See ya.
All right, take care.